Hey everybody, Gabe Jenkins back with you, looking at assignment number 18. 18. First time we've had to do anything like this, and we need to make threads on a shape here. So it's like we got a bolt here, and we got two kinds of threads, like things that we need to make here. Um, Now it's a normal bolt that looks like basically like this. That's like kind of like it's the basic shape of the bolt, right? Like fat top, chamfered edge here, and then the bolt where all the threads are going to go is right here. And I just want to just like talk to you really quickly about threads. You'll see on the assignment there's an additional link to a really excellent discussion about how to make your own threads, which is what I'm going to want you to do here. But just so that you have an idea of what we're looking at here. Um, if we look at it, these are like the threads of a screw. Threads are like the part that you screw in when you're trying to attach some kind of a threaded bolt of any kind. And here is a detail A of what we see up here on the bolt. So it's a really, really close-up view of exactly what each thread looks like. Now, let's talk you through this real fast. This 1.00 right here, that is the distance between between any like identical elements of a thread, like and the next one, right? So like the outermost point here down to the outermost point here is exactly 1.00. I think we're in millimeters, to be honest with you. Let's see, are we in millimeters? It doesn't say. Probably millimeter, because that'd be quite a large screw. We'll say it's millimeters. Um, and what this one represents, it's got a special name, and you might remember it from a different class. But one is the pitch. It's the pitch of the threading, right? So it's basically like the distance between one outermost point and the next point, or the same thing as one innermost point and the next point. It's the pitch. Now, very often, pitch is described in terms of threads per inch, right? So we're going to talk about. I'm going to show you that in a second. Threads per inch. So maybe this is like if there's a distance of, if this were inches and it was 1 inch from here to here, it would be 12 threads per inch because each thread is 1 inch wide at the widest part. It's got inner diameter and outer diameter. So from the outermost point here, which if you look at this picture right here, the outermost point of the boil is exactly 10. And so from the outermost diameter to the innermost diameter is 10 minus 0.41, so whatever that is, 9.59. And then there's this little part right here, 0.18, which ends up being important when you're trying to make your own threads. There's a little kind of flat edge on the end of each thread. So what a thread really is if you look at it up, kind of like think about it logically, a thread is simply a spiral that goes all the way around a cylinder. It goes around and around and around, and along that spiral is like a little V-shaped cut, right? It's a little V-shaped cut that spins around and around and around and around and around, and that's how threads are made on screws. Sometimes they extrude them outward, but we're not going to worry about that. Most of the time, threads are cut out of a bolt, right? To make the screw threads. So the main kind of new thing on this assignment, this shape's simple, right? But the threading is new. So let's come over here. So in SolidWorks, there is they're trying to make things easy for you, and there is a tool that does automatic threading for you. So if you go up here to Hole Wizard, this button right here, if you click on it, it helps you to like install standard diameter holes. That makes it really easy if you're trying to just like design a whole bunch of hole cuts through an object. But if you do the drop down menu, there's another thing here called thread, right? And so if you click thread, it gives you this pop-up, this message saying like, these are not perfectly designed threads. It's just kind of like for viewing only. If you really, really, really want to design your own threads, right? But if we're just kind of like ballparking it here, here's what the toolbar looks like, right? It says you need to pick what's the circle that you're going to design your threads like around. So I'm going to pick this right here, and then it gives me this kind of partial preview of what the threads could look like. And here are kind of the things that you can change about your threads. You can say, how long do you want those threads to go? So right now, they're designed to go 10 millimeters from that starting point up here. I think the whole bolt is like 20. So if I hit 19, it's going to make it go from here 19 millimeters up the thing. If I wanted, for whatever reason, if I wanted to mirror it, I could do that too. I could just say up to the next selection, like up to the next area. I'm not going to do that. Or I could say revolutions, like how many spins around do I want it to go? Do I want it to go, right now it's going 17 spins around. What if I said I only wanted it to go 10 spins around? What does that look like? That's 10 revolutions, 10 times around the bolt. I almost never want to do that. I almost always want to, I know how long that bolt is, and I want to go basically close to the upper end here. I need to leave a little bit of space because threading probably wants to leave a little bit of space. Now, this is where it's important. So where it says size here, right? Well, let's do this. I can do a metric. I can do a metric die, or I can do an inch die. Let's just say we're in inches here. So now I can pick the threading standards. So all of these represent different standard sizes for threads. The first number you see here, 0.375, 0.5, 1, that represents the diameter of the bolt that the threads are being cut out of, right? So like if this were a 1-inch bolt, I could choose that, and it would give me this. Now what that's telling me is that the 1 represents how wide the bolt is. The 8 represents threads per inch. Okay, so these are standard sizes, right? Totally, like if you go to the Home Depot or Lowe's, you're going to see, if you look at the screw section, you will find this kind of standardized numbering systems for whatever kind of screw you want to buy, right? The numbers up here at the top, if I scroll up here, these are metric sizes. The ones that start with a kind of something that looks like a decimal fraction, those are like those are the inch-based sizes, right? So you could just say, okay, I want to. This is I don't know. I don't say that, right? So this is assuming it is a 3/8 inch bolt and 16 threads per inch. So if I just said, okay, cool, it's going to cut those out for me, and that's what it looks like. All right. Now, I'm not going to have you do that. Okay. So instead, I'm just going to delete that. Here's what I want you to know. There's going to be a subsequent video that shows you exactly how to create the V-shaped profile that you're going to cut out along a helix. But just this is how you make a helix. If you go to, you have a sketch with a circle on the end of the shape you're trying to make your threads along. If you highlight that and you go to curves up here at the top and you hit helix and spiral, it then lets you start to just set up a spiral, right? And there's some choices up here. How do I want to define my spiral? Do I want to define it by how high up how tall a spiral I want it to be, and how many and how many basically rotations per cycle do I want it to do? Do I want to define it by height and how many revolutions I want it? What is the pitch, like the distance between each basically thread on the spiral, right? I'm probably gonna do this because this is the way I think about a spiral. Like how many, what's the distance between them? The distance between one. If I zoom in super close, right? It's hard to kind of gauge it, but the distance between here and here, that distance would be the pitch, right? All right. So in this case, the height is going to be 19. Cool. If I wanted it to be only go halfway up the bolt, I could say 10, and then it would only go that far up. Well, let's just say I want it to go almost all the way to the end. I hit 19, so it goes almost up to the end. And then pitch. What's the distance between one thread and the next? In this case, it's 1, but if I, for whatever reason, wanted it to be 4, it'd be a much more coarser threading for the thing. I wouldn't worry about the start angle. Reverse direction just makes it go out if you, for whatever reason, wanted to have something that went out that way. Sometimes you might. But let's just say here, 19 inches up here, and one thread, or a distance of 1 millimeter between each arm of the spiral. So that's how you do it. Now, real quick, you're also going to need to make some basically what are kind of like threads up here. It's going to be knurling with a K, knurling up here at the top. And I just want to show you what this looks like. We'll just say, sure, leave that spiral there. Now, let's say I want to do knurling at the top. So I'm going to make a different spiral up here at the top. And I'm going to want it to come down so the direction is right. The height's way wrong. I don't really remember how long this is. We'll say it's 8. Let's just look back here. How tall is the top? The top is 7. All right. So I'm going to say 7. All right. So now it's going, if I zoom in super close, it's going from the top of this shape to the bottom of this shape. Now I have it as 7. Pitch is, if you look carefully at the knurling, a spiral goes from like here down to here. So it doesn't go all the way around. It only goes like maybe like 20 degrees around the whole circle that's going around. So let's just say I don't want it to go, let's just look at what 10 looks like. So that's if I do that, that's having it go, I don't know, maybe like 2/3 the way around. So what if I make this like 25? That looks more normal. Let's say 35. Yeah, 35, maybe 50 even. Let's say 50, right? So if I do 50, cool. I can then now do a couple of things, okay? If I hit OK. So I've made this one spiral. I can now make a circular pattern of that spiral and have it replicate all the way around, like 50 times or whatever it's going to be. I just want to show you this too. Right now it's going in one direction, it's going clockwise. What if I just like repeated it, but had it go the other direction, this way, right? So if I had 50 going clockwise and 50 going counterclockwise, and cut out a little V shape around all of them, what you would end up with would be something like this, where it's like a little V-shaped cut that goes around here, and a V-shaped cut that goes this way, and you'd end up with knurling. I'm going to let you try to figure that out a little bit, but ultimately what you're doing is you're creating a spiral that doesn't go all the way around, it just goes partially the way around. You're going to make a mirror image of it, basically, a counterclockwise image of it. You're going to circular pattern those around the shape, however many times looks right to you. There's no specified answer about how many times. And then you're going to make a little V-shaped cut around each one of them. Actually, the order would probably be make the shape, make the cut, make a different shape, going the other direction, counterclockwise, and make a cut there, and mirror both of them around. Circular pattern, both of them around. And that's about it. That's about it for helixes and spirals for now. More time to work on it in class and see if you can figure out anything that is confusing about it. The next video on this assignment shows you how to actually make the little V-shaped cutout, and that aligns with these exact specifications. It's going to be set to different numbers, but the process is the same. All right, everybody. Hope that helps, and good luck with it.